Good morning, boys and girls. Today we will be working through lesson 27, in which we will both take a quick look at how to use our fraction pieces in order to help us reduce fractions. And most importantly, we will be looking again at how it is that we add and subtract mixed numbers. So looking at page 128, very first section, we simply have here an example of how we might set out our fraction pieces in order to help us visualize the most reduced fraction. Each of these fractions are the equivalent of 1/2, and by laying out our fraction pieces, we clearly see the picture they create is a 1/2 piece. Some of our other fraction pieces may not be so easy to simply reduce, but if we use our fraction pieces, we can do so quickly and easily. For example, in example 1, we are asked to use our fraction manipulatives to reduce 2/6. Well, we begin by setting out two 1/6 pieces and then looking for a single fraction piece that we can lay over the top. And we would quickly see that our two 1/6 pieces are the exact same size as 1/3. Therefore, 2/6 reduces to 1/3. Now, there are many ways to go about reducing fractions, and you may be very comfortable with some of our other methods, but going back and using fraction manipulatives is always an option and always a good choice. Let's go on now and consider some of the many times that we might need to add or subtract mixed numbers and how it is we might go about doing that. Remember that a mixed number is a combination of a whole number and a fractional part. In general, when we add mixed numbers, we add the whole number parts together and then we add the fractional parts together. When we subtract mixed numbers, we generally subtract the fraction parts from the fractions and the whole number parts from the whole number parts. The only really tricky thing is that we need to study and examine our final answer and make sure that it is written in the simplest form. Looking at example 2, we are asked 2/3 of a circle is what percent of a circle? Well, looking at your 1/3 piece, you see that 1/3 equals 33 and 1/3%. And so if we were to add two 1/3 pieces together, we would be adding 33 and 1/3% plus 33 and 1/3%. So let's begin by adding our fractional parts. 1/3 plus 1/3 is 2/3. 33 plus 33 is 66. And so our sum is 66 and 2/3%. Now that was a fairly simple, straightforward problem. Let's continue to look at the examples in our book, and we will find a few other more challenging issues. Example 3 says 2/6 of a circle is what percent of a circle? Well, looking at our 1/6 fraction piece, we see that 1/6 equals 16 and 2/3%. So in order to solve this problem, we need to add 16 and 2/3% plus 16 and 2/3%. So we will begin by writing that out. 16 and 2/3% plus 16 and 2/3%. Let's begin by adding our fractional parts. 2/3 plus 2/3 is 4/3, and 16 plus 16 is 32. Now, while you might be tempted to say, aha, I've solved the problem, you need to go back and check and make sure that this number is written in its simplest form. In this case, we notice right away that 4/3 is an improper fraction, and we need to simplify it. I'm going to pause for just a minute and go blow my nose. I'll be right back. So, taking out just a quick moment to study 4/3 a little bit more carefully, we know that we can pull one whole group of 3/3 out of there and have 1/3 left over. Therefore, in order to write this problem in its simplest form, we really need to take another quick moment, add our 32% plus our additional 1 1/3% in order to come up with a final answer of 33 1/3%. This then is written in its simplest form. Let's check with what our book has done. We'll turn the page. And they as well came up with 32 4/3%. Noticed that the 4/3% is an improper fraction that needed to be simplified, and then came up with the exact same answer we did. Let's go on and look at another example together. And I'm going to pause one more time and blow that old nose. You can tell it must be the fall season when I am recording this video because my allergies are certainly enjoying themselves. Let's go on and look at example 4. In this problem, we read that Tom lives 2 3/4 miles from school. Tom rode his bike from home to school and then back home. How far did he ride? Well, this is a sum and some more story. He rode 2 3/4 miles to school and turned around and rode 2 3/4 miles home from school. Therefore, we'll set up our problem and begin to add. My whole numbers add up to 4, and my fractional parts, 3/4 plus 3/4, add up to 6/4. Well, we can see there's a problem here. That is an improper fraction. So let's break this down into simpler terms. I can take out one whole group of 4/4, and I have 2/4 left over. Now, if I want to continue to simplify even more, I see that 1 2/4 is really the same as 1 1/2. Now I have 6/4 reduced to its simplest form. To this, I add the 4 from up above, and I see that my total is 5.5 miles. And when we look at our book, we see that they have solved exactly the same way. In example 5, we're asked to look at a subtraction problem. In this case, we are taking 5 3/8 and subtracting, it looks like 1 1/8. Let's begin by subtracting our whole numbers. 5 minus 1 is 4, and 3/8 minus 1/8 is 2/8. I suppose, boys and girls, I really should have started with the fractional parts first in subtraction. That would have been in better form. We will get into problems later on where you have to do some regrouping, so it is always good to begin with our fractional parts first. Anyway, back to the problem at hand. Our final answer is 4 2/8, but we do need to examine 2/8 and see that it can be written in simpler terms. In other words, it can be reduced. So we really have a total of 4 1/4, just as was done in our book. I'm going to go ahead and let you have a practice now. I would like you to do all in practice, and I would like you to write out and show your work on your paper. Have fun with this.